Hello everybody. So let's have a discussion today about extending interfaces. We'll extend interfaces much like we extend classes. Extending an interface is a very powerful tool in Java. It plays into both it as an enterprise level language, and it also helps us declare objects. So keep in mind that when we're creating objects, some objects like our geometric shapes, some of them are round, some of them have 3 sides, some of them have 4 sides. Some of them, they all provide an area. They all they all have an area, and they all have a perimeter associated with them. But depending on which object we're talking about, like a triangle has 3 sides, a rectangle has 4 sides. A regular polygon means all sides are equivalent. Things that are not regular polygons will not have that property. So if we're going to say what is the side length of a rectangle, that may not make sense, because what does it mean when we have 2 different sides? So we have a longest side and a shorter side. That would still hold true for a regular polygon, but a regular polygon means that all sides are the same. So we could still have a longest and a shortest, it would just be the same, but it won't necessarily mean, what does it mean to say get a side whenever you have different side lengths? So if all side lengths are the same and we say get side length, then that makes sense for a regular polygon. So anyway, let me hop over to my IntelliJ, or let me show you where I'm bringing this code in, and then we'll kind of give you an example of what we're creating. So if you look, we're basically going to bring this in through GitHub, through this. I'm sorry, to show you my code base. This is the GitHub repository. It's abstract classroom-java extending interfaces. I would click down, copy this, then we go over here and we're going to do git clone, paste that in there, hit enter, and then we go over to IntelliJ and we're going to say file, open, and then we're going to say GitHub. For this, you guys will be different, obviously, but we're going to say extending interfaces. And I'm going to go ahead and click right down to the folder that contains the POM file, click open, and we're all set. So if we look, what we've got is we've got a code base, untitled, I probably should have changed that, sorry, and we have a main. So notice that main is basically just declaring a rectangle, a square, a circle, and an equilateral triangle, and then printing it out. So these are basically the same things as what we created before, except I've added an equilateral triangle. Now let's look at the shapes library. You'll find out that it's going to be quite a bit more upgraded than it was before. So you see that we have sub packages. One of the packages just has some interfaces where we're defining an eye shape, an eye polygon, an interface for regular polygons. And then inside a triangle, we have the equilateral triangle class. Inside rectangle, we have rectangle and square. Remember, square basically extended the rectangle in the previous lecture, same as before. Then we have the interface package, and then we have the ellipse. So remember, an ellipse, we don't have something, a general ellipse. We just have the circle, which is a special type of ellipse. An ellipse, think of like kind of an oval type shape, an elongated shape, where you kind of have 2 diameters. You have a longer diameter, then you have the smaller diameter, what we call the major diameter, the minor diameter, along the major and minor axes. And then we have a circle where there is no elongation. It's just the same diameter is true all the way around it. Okay, so with that said, let's take a quick peek here. First, at the very baseline, we've got eye shape. That's in our shapes. So we have eye shape. So every shape that we're talking about, whether it be a circle, equilateral triangle, whatever, is going to provide an area and a perimeter. Not so bad, right? And then what we have, I would like to make it clear that we have things that are considered, I don't know, rectangular, and then we have circular objects. So your polygons are things where you have things forming a point, like a triangle, rectangle, square, and then you have your ellipse, which is kind of rounder. So let's look at polygon. A polygon, it has a number of sides, like a square has 4, a triangle has 3. Great. In general, a polygon will have a longest side and a shortest side, right? So I want everybody to take a peek at this. A polygon is a shape that, so whenever we say polygon, notice that it extends eye shape. So eye shape, so anything that's going to be implementing eye polygon will have to implement all of these new things, as well as everything that eye shape required. So anything that's implementing eye polygon, any class implementing eye polygon will have to also provide get area and get perimeter. Now we have a regular polygon, which is a polygon that has all equal sides. So if we're talking about all equal sides, then it makes sense to say, what is the side length of a square? Well, that would be that would be the same length as all the edges in the square. For a rectangle, that doesn't make sense. So a square would implement our regular polygon, but a rectangle wouldn't, because a rectangle has two different side lengths. Two of them, two along the two different ones are parallel to each other. Okay, so a regular polygon, you could say get side length. What does it mean to get the side length of a rectangle? In general, nothing. What does it mean to get it for a square? It just means what is the side length of all equal side lengths, right? Okay. Now notice that we then go on to a triangle. A triangle extends a polygon, right? So a triangle extends a polygon. Okay, so we have that. Now let's go back up and let's look at so whatever our triangle provides, our triangle will require everything to provide this, and it will also require everything for our polygon, which would require everything for our shape. So you see how our triangle extends our polygon extends our shape. So that means our triangle has to provide everything that our polygon guarantees, along with this stuff, and everything that our shape does. Now let's go over to ellipse. Ellipse is a general form of what a circle belongs to, except it's elongated. So ellipse extends our shape, so it means we have to have the major axis length and the minor axis length, as well as the area and perimeter guaranteed by our shape. Then we go into our circle. Now in a circle, we do have a major and a minor axis. It just happens that they're the same length. So then we have a get radius and a get diameter. So our circle requires everything that our ellipse provides, which requires everything that our shape does. Our triangle, as we said, requires everything from our polygon, and our polygon requires everything from our shape. And then you see how we have these nested, basically extending classes that we have. Now, what I would like for everybody to take a peek is that rectangle also has one. Rectangle means that typically we have two parallel sides, but they may not be the same length. So a rectangle, anything that's rectangle, will have a longest side and a shortest side. But remember, that was also from polygon. So if our rectangle implements our polygon, this no longer actually makes sense. So let's look at our polygon again. Our polygon requires get longest side, get shortest side. So notice that we don't actually have to have that in rectangle, because rectangle extends our rectangle extends our polygon. So these absolutely do not make any sense. So we're going to remove it. So your first question may be, why do we have all of these? Well, a rectangle might actually say double get width, because I mean technically we can define things to be a width and a length without designating which one's the longest one, correct? So now we have get number of sides. Now here's something I want everybody to point out. Every rectangle will have four sides. So inside of an interface, what you could define is, since an polygon requires get number of sides, and a rectangle is a specific type of polygon, we could have get the number of sides, which means return 4. So anything that is implementing our rectangle will automatically be provided get number sides. Now, if you look, since rectangle requires our rectangle rectangle implements our rectangle. Our rectangle extends our polygon. Our polygon requires that there has to be a get number of sides. Okay? Well, if we go back here to rectangle, notice that rectangle does not provide get number of sides. It doesn't do it. It just simply doesn't happen. So, but look at the interface. It turns out that the interface can actually do this for us. So anything like a rectangle, anything implementing our rectangle will automatically be able to have the number of sides defined automatically. And this is what this default means. The default keyword means that if it's not defined anywhere else, we'll default to this, and we can put that default in the interface, which means that something could override it if it wants to. I could go into rectangle class and actually change that. But that doesn't mean that rectangle has to provide it. If rectangle doesn't provide it and it implements our rectangle, then it basically gets this for free. So if we look, there are many triangles. We can have an equilateral triangle, we have an isosceles triangle, we can have a right triangle. So all these triangles that would be implementing a triangle, guess what? We're going to define the default number of sides. All triangles have 3 sides, which means we could have the default integer get number of sides. And since it also implements iPolygon, notice that we no longer have to worry about the get longest side, get shortest side. That's automatic. But the one thing that a triangle may not provide is get middle length side. Get middle length side. So we go over here. Notice that it does provide get longest side, get shortest side, get middle length side. It does have all that. Okay. So notice that you have to import these as they go along. Notice that all these things have to be present if we're implementing a thing. And I also want you guys to notice that an equilateral triangle, it is a triangle, but not all triangles have the same side lengths. Like a right triangle will not. But notice that we're able to implement more than one interface. So when we implement more than one interface, that means that equilateral triangle has to provide everything that iTriangle does, and anything that iTriangle extends, chaining through that will also have to be provided. It also is an irregular polygon. So if we look at what irregular polygon means that we have all sides the same, so we have to have a method that says get side length. The reason is because we can start declaring these objects with their interface. And we'll do that in the lecture video. So when we start declaring objects with their interface, it effectively means that we can have the interface, and it guarantees that these objects will provide that. So we can have a regular hexagon, and we can have a regular triangle, and we could have a square. All of these things have equal side lengths. So they need to have, they could implement our regular polygon, which means that they all have the same side lengths, meaning they could have a method, or should have, and will have, a method get side length. So we could actually declare a list of things that are irregular polygons, which would guarantee that they would all be able to provide get side length. Now, anything implementing an ellipse will have a major axis and a minor axis, and they will have lengths associated. But it turns out a circle will still have that, except that a circle will have just a diameter and a radius. So the diameter would essentially be that. Okay, well, essentially would be the same thing as the get major axis length, get minor axis length. Okay, so with this said, this is a good code base to where you really need to dig in and look to see how everything's going together, because it can be quite complicated. Notice that whenever we run this, we get it. Okay, everything runs, compiles. Let's go to equilateral triangle. Let's suppose that we don't have get middle side length. We all of a sudden see that this thing is complaining. When we hover over it, it'll tell you why it must be there. Notice that abstract method get middle side length is in iTriangle. That has to be there because we're implementing iTriangle. Okay, so we decide, you know what, we're going to add that back. It complained, we're going to add that back. Let's delete this one. Now it complains again. Look where it says this is complaining from. It says get longest side is required in iPolygon. Remember that iTriangle extends iPolygon as an interface. So you notice that IntelliJ is basically looking through the chain to see here what's missing. The Java compiler will too, it's just that IntelliJ is very good about it as well. So if you see this, it says you got to have the longer side because that's required in iPolygon. iTriangle extends iPolygon, so that iPolygon requirement has got to be there. Okay, so let's undo that. Let's put that back. Now let's go over here and let's suppose we say we don't need this thing. We're going to say we're going to get rid of get area. Now watch it complain. We're going to say, oh, well, it says this is required in iShape. Remember, iTriangle extends actually both of these extend iShape. So through the change, they both extend iShape. In C++, here's the thing. In C++, you can actually, there's no notion of the interface in C++, but you can extend classes. In Java, you can only extend one class. In C++, you can have multiple classes. That can result in what we refer to as the diamond problem, which will be another lecture that will result into the diamond problem. But given the precedence in the way that Java handles interfaces and classes, and the fact that it can only extend one class, in Java you can only extend one class, C++ you can extend many, leading to a diamond problem. Java does not have the ability to have a diamond problem. If it does, the compiler will complain. Actually, it will complain no matter what. It's just a matter of being able to deduce why it is. So if you're following good code practices, you won't have it in C++ or in Java, but they'll complain. So we have here I triangle and I regular polygon both are talking about I shape, but this won't result in a diamond problem, which we will discuss later. Just notice that it has to be there. It's saying that I shape requires get area, I triangle extends what? I polygon extends I shape, and so get area has to be there. Okay, so basically what we're doing is interfaces allow you to group things together that should have common traits. And these traits can intersect things in really weird ways. So we can have a whole bunch of categories, and the interfaces effectively define how these intersections should behave. Things that have a longest side, okay. Things that have a shortest side, okay. Group them together, create some sort of interface mechanism to where all those things make sense. Look through here, we could say maybe, what do we got? Get longest side, get side length. Okay, so we got all these things. Get side length. Watch what happens when we take this out. Why does it complain here? It says this is required. It says this is required in our regular polygon. So since we're implementing our regular polygon, we have to have this present. So as you can see, this is a kind of a complex mechanism, and I encourage you to really look at this code base, make sure that you understand what's happening, go through here and make sure that you understand all these interfaces. Before, at one point, this packaging up interfaces is common in some places it's not. As you can see, these packages start kind of boiling down into each other. We could, in the triangle, maybe we would create another triangle called right triangle. And then we would say it would implement I triangle, but it would not in general implement our regular polygon. We don't need to implement anything else because I triangle already extends I polygon, which extends I shape. Okay, so with all that said, this is very complicated. It's incredibly kind of difficult to follow at times. But what I want you guys to know is here's a good code base. You really need to make sure that you can follow along and understand. What I recommend is you go into this code base, bring it on your local computer, start playing with it. Notice that the interfaces actually allow certain things to happen. So I could actually change, this will be for another lecture video, but notice that I could actually say polygon. Polygon works okay for rectangle because rectangle implements polygon. Now watch what happens whenever I declare a square, watch what happens when I declare this as a irregular polygon. Notice that it complains because rectangle in general does not fit that category. Notice that square could be irregular polygon because it is a regular polygon. All sides are the same. Circle will not be polygon because it's not a polygon, but it can be declared as an ellipse, meaning that this fits the ellipse category. Notice that we cannot declare square as an ellipse category or interface category because it doesn't fit that. So as you can see, these interfaces and extending them allows objects to be declared in a certain way. So let's be clear, since an equilateral triangle and a square both are both fit regular polygons, that means that our regular polygon can be used to declare both of them. But whenever we use an interface to declare an object, that means that only the parameters or only the methods associated with our regular polygon can be applied. So if we wanted to create a list of squares and equilateral triangles, it wouldn't allow a rectangle because it wouldn't be able to provide side length, but it would only be able to provide length and width, longest side, shortest side, but it wouldn't be able to provide side length because it may not have all equal sides. But if we were to declare a list of irregular polygons, then square and equilateral triangle would be in there. But in that list, the way we declared it, we would only be able to access the things that our regular polygon provide. Even though the class itself may provide other things like the hypotenuse, whatever we might have a triangle do, it won't do it because our regular polygon will only provide get side length, meaning all sides are equal. So basically that interfaces provide a way of kind of controlling what you're asking for. It provides, again, that contract with the outside world about what it will provide. It's a very powerful tool, and in fact, whenever we declare a list, so if we were to declare a list of things, I want you guys to notice that IntelliJ kind of helps you with this. Let me go down here and let me show you one. If we're declaring a list of objects, let's suppose I'm going to say a list of, we got to import that class, a list of regular polygons, and then we say, maybe say we could say a regular polygon list, then we could say list of, we could put square and we could put that in there, correct? And list is actually, so we could say list of, or we could put array. We could allocate a new array list rather. And we could add the square, and we could add the equilateral triangle. So in this case, we've declared this list to be irregular polygons, which allowed us to add the square, the equilateral triangle, the instance of that we give, but it will not allow this polygons dot add, and we're going to say maybe what could we do? We could put maybe the circle C1 in there. Notice that it's complaining because circle does not fit that category. It does not fit that interface. All right, so we've got it. It turns out, here's what I want you guys to look at. Notice that up here, if I was to do this, I could say regular polygon. This is the interface. Interfaces can be used to declare objects, but then the class is what you actually create an instance of. So that's another little kind of trick that's kind of cool of Java that really helps out a lot in enterprise level development. Here, list is actually an interface that is, array list is an actual class. List is nothing but an interface in Java. If you look, you can see where it says public interface. List is a public interface. Hopefully that's what I said. And then here we declare what kind of list it's going to be, and it's going to be a list of interfaces, but that's just declaring the object. So it's going to be a list of polygons to where they implement, either through extension or whatever, a regular polygon interface. All right, so with all that said, that's some pretty cool features associated. So if you guys want to see this, I can actually write a for loop here. For loop, integer I. We won't do an enhanced for loop yet. So notice that it's going to be I equals 0, iterating over the size of the entire regular polygons, incrementing just like you would in C++ or C. And then we're saying print regular polygon. We're getting it, and then we're going to say print to the string. Add a new line here. Print this out. You guys see that it prints out regular polygon 1. This so happens to be a square. Print out regular polygon 2. It happens to be an equilateral triangle. So you can see this is very powerful, and it's actually kind of required. It's very difficult to navigate around this unless Java had this, because if you were to declare a list of rectangles, square could be in there because it extends that class, but interface allows things that may not be able to extend each other directly, but they do have certain parameters. So like you can't say that you could extend a circle from a rectangle or a rectangle from a circle. You couldn't do that as far as a class goes. It wouldn't make much sense to say it's going to extend that like that, because they don't really line up quite right other than just being a shape. But what we could do is we could define an interface to where we guarantee that both will provide a perimeter and both will provide an area, and in that case that's where the interface kind of shines. So you can create classes that behave like interfaces and interfaces that maybe behaves like classes in some ways. You can kind of trade them out with abstract classes, which will be another lecture. But for right now, let's stick to the interfaces and realize how powerful they are. So I'm going to push this repository up. I'll let you guys have access to it. I'll post this video. Do play with this code base quite a bit. Do try your best to play with it and see what happens. Fork that repository so that way you have your own and you can create your own and start playing with it, extending it, whatever. One of the things that I recommend that you do is maybe playing around with creating other shapes and see if you can kind of understand, maybe create your own shape with your own interface perhaps. But in any case, make sure that you understand this. Keep working at it. Keep looking at that code until you see it. Watch this video. Look up other resources online. Whatever it takes to get you familiar with this, do be familiar with it, because this is going to be an important concept that we're going to reuse over and over throughout the semester. So with that said, thank you for watching, and I hope you enjoyed the video, and I will see you guys next time.